Thank you for joining for today's webinar, Energy Efficiency for Developing Countries, pivoting the focus from savings to increased outputs. I'm just going to do a bit of housekeeping. So just to outline the proceedings today, we're going to have a quick introduction, and then Philippe and Joeri, who have joined us, are going to do a presentation for 30 minutes, which is the main part of the webinar today. And then, as you'll see, we're joined by a panel of experts who Nina will properly introduce later, but that will be facilitating a discussion after the presentation on the presentation. And then after that, we'll have a quick roundup for the day as well. So again, thank you for joining. So I'm just a bit of housekeeping. So questions are welcome in the Q&A box. Please just be concise and precise with your questions and give us some context so that we can address them. You can also vote on the questions that you'd like to be seen addressed first. So yeah, feel free to vote on them. And just firstly, to anticipate a commonly asked question, there will be a recording of the session made available of today. It will be emailed to you, and it will also be available on our Energy Evaluation YouTube channel. So a bit about Energy Evaluation Asia Pacific to start. So Energy Evaluation Asia Pacific was kind of formed in 2018, although the thought for it had come long before. We're a group of people, community supporting the evaluation of energy policy and programs. We welcome policymakers, evaluators, academics, and energy professionals to get involved in a dialogue about how best to conduct evaluation and to ensure that good decision making and the wise investment of resources. We have an active planning committee, and we also have 32 evaluation ambassadors from 21 different countries. And you can sign up to our mailing list if you're not already part of it. I'll add the link to the chat, and you can sign up to our mailing list too. I'm going to go ahead and introduce Joeri and Philippe so that we can get going with the presentation while we try and get Nina in. So Joeri is an energy economist working in the Energy Sector Management Assistance Programme of the World Bank, where he leads EEAP's energy subsidy reform facility and support work on energy efficiency and renewable energy. Prior to joining the World Bank, Joeri worked on various energy economic topics, including geothermal resources extraction, oil pricing, and estimated demand for hybrid electric vehicles. Joeri holds MAs in economics from the University of Rotterdam and the University of Chicago, as well as a PhD in resource economics from the University of California. So I'll hand over to Joeri in a minute. And Philippe Benoit has over 20 years experience working in the intersection of development, energy, and climate. He worked for over 15 years at the World Bank and then joined the IEA as head of Energy Efficiency and Environment Division. During his time at the IEA, he managed the energy efficiency multiple benefits work, for which, and Nina was not allowed to say, so he was fortunate enough to work with Nina on this as well, as the author of the multiple benefits report, which has garnered a lot of praise. And he also inaugurated the Energy Efficiency for Emerging Economies program, under which the best thing he did was to hire Melanie Slade as the program manager. And he currently works as adjunct sector research scholar at Columbia's University Center on Global Energy Policy. So Philippe and Joeri, you take the stage.
Great. Thanks a lot. Thanks a lot for that introduction. It's a real pleasure to be here. And we very much appreciate the invitation and the opportunity to share some of our thinking in terms of how energy evaluation applies specifically to the field of energy efficiency, and in particular, what we have seen as a lacuna, something that has been lacking in terms of some of the tools that we deploy. So we're very much interested in sharing with you our thinking and also getting the reactions of this eminent panel as well as the participants. I'm going to share my screen. I have a presentation. Hebe, can you let me share the screen? Right. And can everybody see the screen? Great. So as Hebe mentioned at the beginning, what we're going to discuss in some ways are some issues regarding energy efficiency that relate specifically to the context of developing countries. What we tend to see when we think about an energy efficiency project, you all know this, but I think it's useful to go over it. What we have here on the left-hand side is input of energy use over time. And we know that energy use produces a certain amount of outputs. And traditionally, very much of the orientation is on the fact that when you do an energy efficiency intervention, investment, or project, you end up with energy savings. And the calculation of the project returns is a calculation of those energy savings relative to those outputs. Very much supporting the whole notion that energy efficiency is designed to do more with less, with very much of the emphasis on the doing with less. But the fact of the matter is, when we think about developing countries, where the objective of governments and the like is really to raise standards of living, whether it's in education, health, urban settings, there the emphasis is probably less on the issue of doing less, but rather generating more goods and services. And that requires, in some sense, looking, when we talk about energy efficiency, flipping the emphasis from consuming less energy to, more importantly, the additional goods and services that energy efficiency can provide. So rather than the energy efficiency energy line coming down, the critical issue often is the fact that you can get more goods and services. This would be illustrated, for example, by cases of energy efficiency in industry and the like. So one thing that we felt was important was to try to change the emphasis and focus from input savings to more outputs from energy. And the other thing is actually, in some ways, it goes beyond that, because when we look at this at a macro level, the estimates from the IEA and others is that across advanced economies, developed countries, they're really projecting reductions in overall energy consumption. And that very much contrasts with what is projected to happen in developing countries, where we're seeing fundamentally more energy will be consumed in the future. And that then in some ways even has impacts when we go back to this project design and this analysis, because rather than simply a question of more goods and services from energy, what we expect often and what is hoped for is really additional investments in energy. You have here a renewable energy, but we also understand sometimes it may be energy sources that involve some carbon emissions, for example, natural gas and like. But the fact that what's important here is that this additional energy, through energy efficiency, allows us to generate even more goods and services. So what we do under this sort of narrative and formulation is we're moving from a very much of an OECD orientation on doing more with less to more outputs and actually even more outputs from more energy. This is in some ways what is potentially of most appeal to developing countries. And so what we sort of tried to think about and what we've been discussing, and something actually that Melanie and I worked on many, many years ago at the IEA, is how can we change the narrative? And having said that, in this particular exercise, what we focused on were certain constraints to shifting the narrative that have to do with the analytic framework that is put out by various multilateral development banks and other organizations. So one of the major constraints is the dominance of the OECD-oriented perspective on energy savings. Energy savings, increasing profitability, but very much tied into the issue of energy savings. The second thing that is very important, and this is very much the genesis of this particular project that Joeri and I worked on for SMAP and targeting the World Bank, bit of relevance to other people, is the fact of the matter is there seems to be relatively few energy evaluation methodologies targeting energy efficiency projects that look to the incremental value of the outputs as distinguished from the benefits of energy savings. In fact, we did an extensive literature review of agencies and the like, and we found very, very few cases where the analytic methodology put forward to analyze these projects looked at increasing outputs. It tended almost to always look at, without exception, energy savings. There were certain cases where it did look at the increasing value of energy outputs. In particular, and I'll come back to this, the case of the rebound effect. But if I could just spend a couple of moments on the rebound effect itself, often the rebound effect is characterized as a negative. Why? Because that's very much in line with the notion that the purpose of energy efficiency is to reduce energy consumption, and the rebound effect will reduce that desired impact. But the fact of the matter is, when we start thinking about the value of outputs, when we have what we call a rebounding demand, there is a rebounding demand that has with it an associated increase in outputs. And those increasing outputs connected with that rebounding demand also in and of themselves generate some value. And then the last thing that we sort of found, this may be true within the World Bank context, but also in other contexts, is that when we're thinking about increased outputs, so for example, buying more efficient industry equipment, the fact of the matter is the change that is occurring has to do with increased production of widgets, increased production of steel or the like. And when we're thinking about the valuation of that from an energy perspective, it's a lot easier for us as energy experts to think about what is the delta and the value in terms of savings in energy, and much more difficult to think about what is the value of the increased steel and the like. It involves sort of reaching outside of our sectoral expertise. And what we have found is, in some ways, even that sort of small dynamic maybe creates a certain constraint. So what we did in terms of the project, and with this sort of focus on outputs, was basically look to redefine the typology of energy efficiency projects as it is used within the World Bank energy efficiency evaluation context. What you have here is a table that sort of summarizes the classic projects that we have today. The first would be a brownfield energy efficiency project where the objective is to reduce energy consumption or to reduce related greenhouse gas emissions or to increase profitability, again, within the notion of fundamentally the way it's going to be valued is through some reduction in terms of energy consumption. And you have these columns. The first column A is the level of goods and services. Basically, the evaluation done consistent with the first chart I noticed assumes that we have static outputs. The second column has to do with what is the expectation in terms of overall energy consumption. Again, consistent with the first diagram I put up, energy consumption comes down. The third one is the energy consumption per unit, the specific energy consumption in more technical terms, that also comes down. And basically, the project's benefits are the result of the interplay between the reduction in the second and the third column and the fact that the first column remains stable. The other classic project that we look at, obviously, are supply side energy efficiency projects, where by reducing technical losses or the like, we can see an increase in energy consumption. But by focusing on the outputs issue, what we felt was that there's another type of brownfield project, another project where, for example, you could have replacement of air conditioning or the like. In this particular case, again, what you're looking at here isn't so much to keep your outputs level and to reduce your energy consumption, but rather the focus is on increasing the outputs. An air conditioner that can cool a larger space, equipment that can produce more steel, more widgets. In terms of the column B, the absolute final energy consumption, well, in some cases it could go down, in some cases it might stay the same, or in some cases it might even go up. But having said that, in all cases, consistent with the first brownfield type of project, you would have a reduction in energy consumption per unit. But it was this really second project that we started to realize there's a lack of methodology and emphasis out there in terms of the World Bank's approach and actually the approach of other multilateral development banks. One point I would like to make here that is relevant to this. As we started again to think about this issue of outputs, coming back to the rebound effect, we realized there tended to, again, to not be sufficient emphasis put on the need and the importance of evaluating what is the incremental output you're getting. Good illustration would be improved energy efficiency in vehicles. Now you get to go to the movie theater more often. That's a rebound effect. But in going to the movie theater, there is in fact a value associated with that. And as one starts to shift the focus from what's happening on the input side to what's happening on the output side, we started to realize there were a variety of areas where in fact what's happening on the output side is not getting adequately addressed. And a related point in this regard was actually to look at the issue of what we could call greenfield energy efficiency projects. Namely, for example, street lighting in India. There's unserved areas in India without street lighting. And in some sense, when you're thinking about making an investment with energy efficient poles, you could do two things. You could replace existing street lighting, or maybe alternatively, what you could do is expand the street lighting infrastructure, what we can call energy efficiency greenfield projects, putting street lighting, efficient street lighting in areas that previously didn't have street lighting. What would be the effect in terms of impact on the level of goods and services? Once again, rising. But importantly here, what's the impact in terms of absolute final energy consumption? Definitely rising. And in this case, the unit cost as compared to the counterfactual becomes less relevant. But what I wanted to say was, because of our approach in terms of focusing on energy, on outputs from energy investment, what we started to realize were these lacks and weaknesses in the existing analytic framework that an institution like the World Bank was using. Just to summarize, to emphasize that there are type 2 projects where the objective of the replacement of equipment is focused on increasing goods and services, and that this has implications also when we think about the rebound effect, that it isn't always a negative, that it's important, even if it is a slight negative in projects, to value the outputs. And the third thing was to very much focus in on the fact that, well, when we're thinking about putting in efficient street lighting or air conditioners, maybe it's important to not just simply limit ourselves to replacement situations, but also to consider whether another project alternative of expanding the infrastructure base would be relevant. And with that, let me turn it over to my colleague, Joeri.
How's that look? Can you see it?
No.
Okay.
You have to share?
Yes, I did. Try again. Can you see the screen?
Okay, we've got it. We've got it.
Okay.
Yeah,
And now the presentation? Okay, great. Sorry about that. Thank you, Philippe. So yes, guidance for economic analysis at the World Bank. Well, generally all projects are evaluated based on net present value discounted at the social discount rate and the economic internal rate of return. However, in the energy sector, comprehensive guidance was only first created in 2017, and I think we are the first practice to do this. This was very much thanks to the work of Peter Meyer, with who we collaborated over the past 3 years, and it's a living document, so we're still improving it. So at the time when we were working on this project, we realized that the guidance for energy efficiency was very much focused on these category 1 and 4 projects, and there was room to sort of expand this. So we developed an addendum to this guidance, which, just to recap, broadens the framework for economic analysis to include projects that increase goods and services, dispels the idea that the rebound always reduces benefits, provides guidance on general steps to do economic analysis, and highlights the importance of project counterfactual. So the counterfactual, of course, is always crucial for economic analysis, and typically it's the next best alternative, the opportunity cost. And two common counterfactuals are an alternative scenario, a counterfactual that yields the same level of goods or services, and a status quo, a counterfactual that does not change the level of goods and services. So let's take one of these at a time. With an alternative project counterfactual. So suppose you have a category 2 type brownfield energy efficiency project, which increases goods or services. Project could, for example, be a buildings retrofit project, and that increases energy efficiency and comfort levels. So the improvement in comfort levels here is the improvement in services. So the counterfactual could be a similar project, but one that uses maybe a conventional heating technology to raise ambient temperature to a similar comfort level. But the benefits that the project delivers are in achieving the norm temperature with less heating fuel than the counterfactual, resulting in energy saving and GHG emissions reductions. Now let's take a category 3 greenfield EE project that increases goods and services with the same counterfactual. Installation of efficient ACs in public buildings, for example, which have no cooling. The counterfactual could be one in which conventional ACs could be installed to provide the same level of cooling. So the project investment delivers the desired cooling levels more efficiently than the counterfactual, resulting in energy savings, GHG emissions reductions. So this is quite standard, right? And this has been done by our energy efficiency colleagues for a long time. It was never formalized, so this guidance formalizes it. And we refer to it as adjusted baseline methodology. But interesting to note, though, that in many World Bank projects, even these type of projects, the outcome indicators are noted as energy saving and GHG emission saving, although the fact is that the project is increasing energy consumption and GHG emissions are increasing, just not relative to a counterfactual. Then let's look at the situation where we have a status quo counterfactual. That is, there's no increase in goods or services in the counterfactual. Suppose again, we're doing a brownfield energy efficiency project, which is a water supply project that improves service levels, such as number of water supply service connections, increased hours of supply, etc. Measures could include upgrade and extension of transmission mains, treatment plants, etc. So then we estimate the value of the incremental goods or services provided by the project, right? So the avoided direct coping costs, this could be construction of household water tanks, purchase from water vendors, avoided indirect coping costs such as reduced time and wage loss because households receive a private connection instead of relying on public taps. And we estimate the value of incremental water access due to the increased hours of supply. Then there's the question of how does energy consumption change? So the energy efficiency of water supply would be improved by, for example, greater efficiency in pumping. So in terms of specific energy consumption, units of energy consumed per unit of water supplied increases. However, improvement of service levels could require more energy, and the net effect could be a reduction or an increase in absolute energy consumption. The change in GHG emissions would follow directly from this change. Finally, a greenfield energy efficiency project with a status quo counterfactual. Suppose you're installing efficient streetlights in an unserved area. Counterfactual is no streetlights, so the project benefits are improved safety, reduced traffic accidents, benefits from stimulating local commerce, etc. And you're estimating an increased energy consumption associated with GHG emissions from new street lighting installations. So what you'll notice here, and this is also something we highlighted internally and Philippe just mentioned, is that the benefits here require expertise across sector. And this is something that we've noted that needs to happen within our organization, that energy economists need to talk to water economists in order to do this type of analysis for these types of benefit and estimations. So what about the rebound effect? Well, as Philippe mentioned, a rebound could be reflective of greater consumption of goods or services. For example, an LED that is left on longer after replacing an incandescent bulb could provide additional lighting benefits. If the economic model is quantifying the value of project goods and services, it's able to quantify the rebound simply by following the same steps. If not, though, one can make assumptions about the minimum value associated with the direct rebound. And the price of energy paid to produce a good service may provide a minimum threshold for willingness to pay of that service, for example, or for example, the energy cost for keeping the light bulb on. So let me just illustrate some of these concepts with the case study. This is efficient ACs for public buildings in Ghana. The case selection was based on an investment proposal we had at hand at the time because it gave us the necessary parameters to do the analysis. The context is one of, there was an audit of ministerial buildings and they found that ACs accounted for 70% of energy consumed with a typical coefficient of performance, COP, of 2.5. So the COP is just a measure of energy efficiency. The higher, the more efficient. Current energy performance standards required imported ACs to have a COP of no less than 2.8. So consider two investment alternatives. On the one hand, there's a brownfield retrofit replacing inefficient ACs with efficient ones, rather than a business as usual AC. On the other hand, a greenfield investment directly installing efficient ACs in a space that would otherwise remain unair conditioned. So I'm sort of mixing two examples here, which might be a little bit confusing, but it's just to illustrate some of the concepts. To simplify matters, let's just assume the buildings are identical, cooling output requirement of 245 kilowatt-hour per meter squared per year. This is cooling output, not electricity in units of electricity. The cooling output is calculated by dividing that number by the COP, which is 97 kilowatt-hour per meter squared per year. Some other assumptions, the AC efficiency is 2.5, the COP, sorry, for the existing, 2.8 for the business as usual, 3.8 for the new. An AC lifespan, existing ACs are due to be replaced. New and business as usual ACs have a lifespan of 15 years. Cost and benefits include capital costs, fuel costs, cooling benefits, and GHG emissions, which we're here valuing at what we call the social cost of carbon. At the World Bank, that starts at 40 or 80 US dollars per ton in 2020 and rises at an annual rate of 2.2% afterwards. So here's a typical results table that's printed in every project economic analysis. Here illustrated for the brownfield and the greenfield investment. We have the economic rate of return as one of the objectives or key measurements. The costs in discounted terms, benefits in discounted terms, and net economic flows, both excluding the cost of carbon and including cost of carbon. Here I'm just looking at the low cost of carbon. And to make matters even simpler, the net present value here is shown just for 1 square meter of building because all costs and benefits in this case can be scaled by the size of the building. Take the brownfield investment, for example. You don't have to look at all these numbers, just at the net economic flows. The net present value of 12.8, including the cost of carbon, and 19.8, sorry, 12.8 excluding the cost of carbon and 19.8 including the cost of carbon. And because you're replacing less efficient AC with a more efficient one, of course, when you're including cost of carbon calculation, you're increasing your project economic benefits. What about the greenfield though? Well, if we don't know the incremental cooling benefits, we cannot estimate this. But so which investment alternative is preferred when the willingness to pay for cooling is unknown? Well, switching value analysis can always provide valuable information to start. So suppose the objective is to maximize net present value excluding GHGs. So what number would yield, what value for willingness to pay of cooling would yield the same net present value here? And that number turns out to be 4.6 US cents per kilowatt hour. Now, taking this number back to a real world example, suppose your office is 20 square meters. Then you would need to cool it with an equivalent of 4,908 kilowatt hour per year, which would provide you 228 US dollars per year in terms of benefits and cost you $104 per year in fuel and $740 capital investment cost. So that's one number. But we also observe willingness to pay for cooling based on existing infrastructure and existing energy use. In existing buildings, a tariff of 22 cents per kilowatt hours is being paid by the government of Ghana, and the ACs have an average COP of 2.5. This implies they're paying 8.8 cents per kilowatt hour. So one could say this is a measure for willingness to pay for cooling. Note, if the rebound were also observed in the retrofit case, it could reflect a willingness to pay for cooling of 5.8 US cents per kilowatt hour, based on the fact that you're also paying 22 cents per kilowatt hour in that case, and the efficient AC is 3.8, has its COP of 3.8. So we can derive values for willingness to pay for cooling from observed consumption behavior. Of course, you always need to be careful. For example, the BAU AC in one building may be different than that in another building, or the willingness to pay for cooling in some buildings may be higher than in other buildings. So there's, of course, all kinds of uncertainties, and that's why sensitivity analysis is always an economist's good friend. Let's look at the critical parameters here of uncertain value. For a brownfield energy efficiency investment, this would be, in this case, the efficiency of the business as usual AC. So here we have the efficiency of the business as usual AC increasing along the x-axis, and on the y-axis we have the economic internal rate of return. What the chart shows is that the higher the social cost of carbon, so going from the blue to the gray line, the higher the economic internal rate of return. And of course, the higher the efficiency of the regular AC that would have been installed, the lower the economic internal rate of return. The yellow line here is the social discount rate, which is sort of the threshold value that we use to determine whether a project is viable or not. Then on the right here, the most uncertain parameter in the greenfield case is the willingness to pay for cooling. So similar graph, except that now you see that as you increase the willingness to pay for cooling, of course, the economic internal rate of return for the greenfield investment goes up because you're creating new goods and services. However, here, as you're increasing the cost of carbon from no cost of carbon to the high cost of carbon, your economic internal rate of return declines because you're using more energy. So this is So let's combine this what we learned before. A switching value of 4.6 cents per kilowatt hour was found to be the level above which you would prefer the greenfield. And from observed consumption, we see a willingness to pay for keeping an old AC running at 8.8 US cents per kilowatt hour. If that second figure is anything close to what we think the more realistic willingness to pay for cooling is, then we would say, in this case, we would go for greenfield. Combining this type of information, you could create decision matrices such as this. Here, darker shades refer to higher net present value, and the different colors show you what investment decision you would make. So if your willingness to pay for cooling is relatively low, you would either do brownfield or no project, depending on the efficiency of the business as usual AC. But as long as there's a high willingness to pay, you would go for a greenfield, because those new goods and services are providing way more benefits than energy savings could. Then another interesting to note from this analysis, we thought, was that if you look at the life expectancy of existing ACs. So this chart shows you on the x-axis what the remaining lifespan is of existing ACs that are due to be replaced in the brownfield investment. So say, for example, there is a high social cost of carbon. So you have an economic internal rate of return of 50%. The second that AC that you're going to replace has one more year of service life in it, your economic internal rate of return drops to 30%. So for a retrofit, a longer remaining lifespan of existing equipment lowers the project EIRR because it delays the capital investments in the counterfactual. With high discount rates in developing countries, which impact the discount rate, for the economic analysis, the impact, you can see the impact is quite significant. In Ghana, the economic internal rate of return for brownfield investment drops by more than half should existing ACs be able to keep running for 2 more years. So, yeah, this is just to show again that that in the example that I had before, we were assuming that the brownfield looked at the moment when the existing AC was on its last legs, absolutely on its last legs. But in developing countries, if you have existing infrastructure that's providing services, then very quickly providing new services can give you higher economic returns than replacing existing infrastructure. So some conclusions. Guidance documents on economic analysis of EE projects at MDes and other international organizations focus almost exclusively on energy savings. This is in part because it is often difficult to quantify the value of goods and services, and the economic internal rate of return is based on energy savings alone is often high enough anyway. Where energy investments yield additional goods and services, benefits can often be estimated based on energy savings, provided a realistic counterfactual that yields the same goods or services less efficiently. However, where the project is not designed to provide the same level of goods and services, the additional value of these would need to be estimated with cross-sector expertise. Identification and analysis of EE opportunities based on energy savings and GHG emissions alone can eliminate viable investment opportunities that efficiently produce more goods and services from consideration, especially in developing countries. And this work aimed to shift this narrative by recognizing EE as a means to increase production of goods and services, broadening guidance of economic analysis of EE projects, and reframing the discussion on rebound effects. Thank you very much.
Thank you, Joeri and Philippe. I will, if everybody can hear me, I'll take the floor now okay, great, to share on behalf of everybody. Thanks for that really interesting presentation. There's a lot of content in there, but I think some really strong messages come through there around something that probably, I think a large amount of our audience in the energy evaluation Asia Pacific space are familiar with, the issues around the conflict between saving carbon, saving energy, and improving living standards, quality of living, and supporting development. So having these really concrete tools to start to bring some of those benefits to bear and balance that scale between energy saving, carbon saving versus development is really powerful. So thank you very much for sharing that experience and those tools with us. Now I do need to apologize because I was supposed to be here to open the webinar for you, but I had a technical problem at my end. So here I am now, and thank you, Hebe, for getting us started. So I think Hebe's already explained to you why we're here and what the Energy Evaluation Asia Pacific Network is about. So what we wanted to do is, certainly we're interested to hear from, I'm sure everybody's sort of processing that and might have some questions that they'd like to put to the speakers. We now have 20 minutes where we can have a bit of a discussion about what we've heard, and it would be really interesting to hear from our participants the extent to which this sounds feasible in terms of your experience working in the field in the Asia Pacific region or beyond. And I guess obviously any questions that you might have for the speakers, so questions of clarification or to dive into any of the detail. Now, as Hebe said, we would like you to put those questions into the Q&A box, and we'll keep an eye on that. If any come through, we will put them to the speakers. But in the meantime, we're very fortunate to have a really interesting panel of discussants with us today who are going to contribute their thoughts and reactions to the content and guide us through a bit of a discussion on this. So I will, without further ado, introduce our discussants. And then I'll ask each of them to give a bit of a reaction and pose any questions they might have. And then we'll get into, we'll see where the discussion takes us. So we've got Amandine from Econoler here with us. We've got Melanie Slade from the International Energy Agency's Emerging Economies Division. And we've got Shingle Sebastien coming to us from the SELCO Foundation. And I might invite Amandine to give us her reaction first, and then perhaps we'll just work through the other speakers and we'll just see how we go. So Amandine is a senior energy efficiency expert and project manager at Econoler, which is a Canadian consulting company. She is an engineer by training, and she has over 15 years of experience working in project and program design and evaluation, as well as project management in the field of sustainable energy. She's conducted or participated in many projects and program evaluations in the energy and climate sectors for a range of donor organizations, including AFD, the IEA, UNEP, Evaluation Office, and the World Bank. So Amandine, I wonder if you could share with us your reactions to that material and perhaps just how feasible that sounds for you from the sorts of projects that you deal with.
From my point of view, it sounds very interesting and very logical to approach different, not only the energy saving, but also all the goods that can produce. Recently, I've worked for the World Bank on a policy design for Argentina for energy efficiency certificate. And we did not such detailed analysis, but a start of analysis of different benefits that could reach from the policy. So it's a very good start point. And I think when you look at our policy, our energy efficiency program, it could be very good to include this kind of analysis during the design. So the decision that you'll make based on the willingness to pay and also the cost of carbon will be incorporated into the program, and it might change a little bit the design, because usually what we looked at, it's only like energy saving and cost saving. So I think it would be a very good option, but it would need like some structure, because up to now we didn't see like so much references and literature on this. So it's like, as a consultant, we can base on our expertise, but it would be good if we can have some like guidance on it. So I really appreciate that the World Bank is working on this.
Thanks, Amandine. Actually, I had a similar thought, which was around, you know, as evaluators, we tend to more often than not come in at the end of a process or a project and are asked to look retrospectively at its impacts. And so, as you say, sort of thinking about this potential to measure this wider range of impacts at the design stage will be really powerful. And the thing I was wondering was, what sort of data would we need to be thinking about gathering that we perhaps haven't done in the past? Whether Joeri or Philippe, do you have any thoughts on what advice you would give to somebody who was trying to plan this up front, about how you might set yourself up to be able to do this?
Joeri, why don't you start?
Yeah, so it's a bit of a chicken and the egg, I would say. You know, you really have to encourage collecting of such data. I think I made a reference to that. Oh, maybe I didn't, but you know, to understand, for example, the value of cooling, right? In a country like Ghana, I mean, you don't start from scratch. Sometimes you have to look at what's being done, what's been measured before, what's being used. So it is rather tricky. And I think that's part of the challenge, which prevents us from moving a step towards that direction, right? Because we don't have that data often. So I think what we are simply recommending here is to make that step and apply it consistently, because without such a step beforehand, then we won't move in that direction.
Right, so if I could just jump in real quickly on 3 of those dimensions. The first thing, right, that's one of the challenges. You do a street lighting project, an energy efficient street lighting project, you need to know what the value of the incremental street lighting is in an unserved area. And that's the type of data you'd have to gather that we're not used to gathering a lot of time in energy efficiency projects. The second thing is I just wanted to point out that this work is actually captured in a document that is available on the web. Joeri, maybe you have a chance to put in the chat, or we can send you, Nina, the URL where the report is available. It was funded with.
Yep, I can put that in the chat.
Right. So it has some background there in terms of methodological. Mm-hmm. And then the third thing, coming back to something Amandine mentioned that I should have mentioned, is one of the big constraints we have in terms of this pivot is that a lot of the funding for energy efficiency projects in multilateral development banks is climate funding, climate finance. And climate finance's whole orientation is on reducing emissions. And if you think about the Leaders Summit that just took place, getting to net zero, it's all about reducing increasingly absolute levels of emissions. And so this type of pivot to outputs where we're recognizing, for example, in a greenfield project, you may have an increase in emissions, doesn't always fit so well with a lot of the source of financing. So we need to be able to get over that issue too, because we know at the end of the day, to promote development, you need greenfield projects.
And actually, Philippe, your reference to the document was useful too, because Amandine was talking about the lack of other work in this space to refer to, but I know that your report did do a review of the existing literature, so that would be a useful resource for people to take a closer look at. Okay, well, why don't we move along, and I'll introduce Mel, and of course, everybody feel free to throw in any questions into the Q&A or chat box as we go. But Melanie Slade is also with us. She has come to us from the International Energy Agency, but she has spent 30 years in energy efficiency policy development and implementation in many parts of the world. She started out working in the UK government on industrial and appliance energy efficiency, and has worked with many other governments as to establish similar programs, perhaps most notably the government of China since the 1990s. In 2007, Mel became the chair of Australia and New Zealand's Equipment Energy Efficiency Program, where she led the phase out of inefficient lighting. And Mel then moved to the International Energy Agency. That was in 2014, where I had the pleasure of working with her briefly. And there she manages still the Energy Efficiency and Emerging Economies Program. So Mel and her team work with policymakers in a range of emerging economies in Brazil, China, India, Indonesia, Mexico, South Africa, and Thailand, where they develop more effective energy efficiency policy, track its progress, and assess its potential. And although Mel is not an evaluator herself, she is very much a client of evaluation services and is active in the Energy Evaluation Network. And she is keen to support the development of policy evaluation skills among officials and the growing evaluation community emerging and developing communities. So Mel, we're very pleased to have you with us. And yeah, if you could share whatever reactions you have from the material you've seen, and feel free to ask any questions or pose some other comments. Anyway, the floor is yours.
Thanks, Nina, and thanks for the opportunity to be here. My comments, I think, come back. I'd like to kind of raise the level slightly and say why this is so important. Philippe mentioned lots of the funding being climate, and we are obviously keen to see energy efficiency in particular do its job, do its best in terms of reaching climate goals. And it's not happening. So the rate of progress on energy efficiency is very slow. It's about half the pace it really needs to be. And I just wanted to emphasize how important this approach is to changing that. As others have said, the governments of developing and emerging economies aren't motivated by energy efficiency projects in their own right. Why would they be? They've got bigger fish to fry, other problems. And just to give you two examples of where really, really good progress has been made, just to make sure that this is grounded in reality. So India, for example, has made huge progress on both energy efficiency and renewables, solar in particular. Why have they done that? They've done that for energy security reasons. They've done that to reduce the costs of importing oil in particular, and their vulnerability to the international oil prices. So that's what's motivated India, and that's what we have to value. What have they done with that money that they didn't have to spend on importing oil? So by growing their local energy resources, that's our issue. China's another great example. Arguably made the biggest progress on energy efficiency of any country anywhere. And was that for energy efficiency's sake? No. Climate? No. Mainly considered to have been driven by local air pollution issues and the quality of life. They've saved money on improving people's health, in effect. And we need to be able to value that in order to motivate other governments to follow suit. So these are real examples that have made huge differences that are following this approach. And of course, you know, we can't observe this moment in time without saying that the biggest issue at the moment, the biggest motivating factor at the moment is economic development and jobs. We're seeing energy efficiency, as I said, it's not going fast enough. We're at a risk of it being scaled back at the moment, not going forward at the pace that we need to see it. So in this evaluation community, we need to get better at valuing jobs. But it's not just, you know, a job's a job. It's which jobs are the most useful in emerging and developing economies. So you know, our analysis last year suggested that energy efficiency in buildings in particular was one of the best places to put your money, because you get long-term, high-quality local jobs. You know, all jobs are not equal in clean energy transitions. We have governments in emerging economies who are you know, struggling with the transition from fossil fuels, from the people who are involved in those industries. And whilst we're seeing the ability to create new jobs through clean energy transitions, they're not necessarily accessible to the people who are losing their jobs. So we need the evaluation community, we need the evidence base to help us understand the winners and losers. You know, how we can create those jobs, those transitions to those jobs for the people who need them. And I just have to say, as I would, that when we're doing this, of course, we need to make sure that the 50% of the people on the planet who are women are taken into account when we're talking about this job creation, and the 50% of the people on the planet who are under 30 also need to be taken into account when we're looking at this transition. So that's a very complicated job for evaluators, to unpick all of that, to collect the evidence on which to build those more effective policies. But if we don't do that, I think energy efficiency is really going to lose ground in this time when governments have to be completely rightly investing in economic recovery. So I'll leave it there for now.
Brilliant, thank you, Mel. That was really good point, just to remind us of the context that we're working in here, and as you say, particularly post-COVID, that economic recovery is really number one. We're working really hard in New Zealand government to improve our practice around valuing jobs and having that information, feeding that information in at a stage of the policy decision making and investment process where it can actually influence what gets funded. And as you say, energy efficiency comes out in New Zealand's calculations as well as a very attractive policy investment for those reasons. I wonder, and it sounds from what you're saying as though there certainly will be a market for evaluation projects and evaluators who have these skills in the developing world. So it'd be really interesting to watch the space and see how people, and actually to share people's experience, I guess, of offering this as a service to governments, policymakers in the developing world. So I hope that our audience listening will not hesitate to reach out to Energy Evaluation Network and share any experiences you've got, as well as any resources that perhaps are work that's been done on the sorts of projects that Mel has mentioned that are already underway in the energy efficiency space. Now, I will, we don't have any questions coming through that I can see yet. Actually, we do have one, but before we're going to, I'll come back to that question, which I think everyone's going to be interested in. Before we go to the one from the floor, I will introduce our third discussant, who is Shingle Sebastien. He's come to us from SELCO Foundation in India. He is a program manager there working in the livelihood space. So I'm very interested to hear his reactions to the material and the opportunity for this methodology to be applied. He's an electrical engineer and also a solar systems designer with 8 years of experience in the clean energy sector. And he has worked extensively in solving problems and identifying solutions in the space of livelihood, energy nexus, and healthcare energy nexus. So thank you very much for joining us, Shingle. Really interested to hear a bit about what you do at SELCO Foundation. That livelihood space sounds fascinating and hopefully quite well connected to what we've been talking about. So any reactions from you to the material or the discussion since?
Yeah, thanks, Nia. Thanks, Philippe, and thanks, Joeri, for the presentation. So while Philippe was presenting, so whatever he is saying, it is exactly sounding as what we do on the ground. So I was just thinking about an example or a case study to just relate to what Philippe was saying in the starting. So so you have heard, everybody knows about the swing machine, which used for tailoring or stitching. So in the villages, it is mostly done by the women. So the traditional one, which is they've been using at their home, is pedal driven, which they will be using, which they will be continuously pedaling for throughout the day, and which will bring the drudgery and cause health issues for them. So what is the immediate remedy which they would be thinking about to replace run the machine with a motor? So they will go to our local market, they'll buy a motor, whatever HP, like 0.25 HP, 0.5 HP motor, they'll run the machine. It in turns reduce the drudgery, but it's actually increasing their electricity bill, and which they will not be so much knowing it before installing the motor, and which is it is actually decreasing their safety nets. So when we got this problem statement, we was identifying the what is the right energy requirement. So there the energy efficiency bit comes in, and we could replace that 0.5 HP motor by a 60-watt PMDC motor. So as a whole package, I just don't want to elaborate, but as a whole package where they were like some of a 0.5 HP machine with the solar powering for the same we say entrepreneur would be somewhere around 1,000 USD, and where we could able to replace with the motor and with the solar we could bring it down less than $300. So which means that more the energy efficiency bit has gone more, and the cost capital investment is less, and then the more energy, because previously the power cut issues would be hindering them in decreasing their productive hours, where replacing with a DRE solution is actually more energy giving to them, which in turn increasing their outputs, or how they are, the time they could do it more extensive time. So the same thought process has to be incorporated into heaters, into compressors, into I would say the motors. Exactly, these are the three main areas where from the livelihood spaces where mostly we use the machines from, and this is where the energy efficiency drive is so much needed and so much need to be focused much. And when we talk about from the Indian context, so the more the energy efficiency here, the energy efficiency is being rated with the Bureau of Energy Efficiency star rating. It comes in 5-star, like that's a maximum star. The more the star rating, if you are going for a refrigerator or some sort of TV or something, television, more energy efficient, more the cost. So how like a middle class man would not be able to when I'm having a $150 refrigerator versus a $300 refrigerator, initially I would definitely, like the middle class man, everybody, they will be going forward for that $150. So how to cut down that capital cost when we have more energy efficiency, when we don't have to invest more into it. And just to come just to have some thoughts with the Joeri, the presentation which she has made, and the air conditioner for a building is actually also have aligned factors such as the doors, which is having the window panes. There are allied sectors where actually even if you replace it with an energy efficiency air conditioner, the runtime of the compressor won't come down. So how like a green building where active and passive methods both are looked into a space where energy efficiency is not only for for an active sense, it's also from a passive sense or from a behavioral change sense, all can be incorporated. Yeah, this is what
Thanks for that. Yeah, it's really helpful to have some more concrete examples of the sorts of situations and benefits issues that we're going to need to try and apply these methodologies to. And I'm afraid that brings us already to the end of our time. I feel like this is a topic that we could have probably got another hour discussing, but I think that probably just is added motivation to get on to our next webinar as soon as possible, and perhaps we'll continue in this theme. But I will have to wrap it up there for now. One, I will just put the last question that came through the chat forward to you, which was interest in your next steps or plans to progress the work. And I think I would say, you know, we will circulate some information about that to the group if you can share it, because I think what we should do is continue this conversation going through our network around people's experience with trying this, and then feeding any developments of your own work out to the group as well would be great. Is there anything that you can say? Is there anything immediately on the horizon? Joeri or Philippe?
I guess internally, we're really trying to get our colleagues to use this framework, because, you know, every economist has a different background, and getting consistency across economic analysis of projects, I think, is always an objective of the work we do.
Right, great. Well, good luck with that. I think as well, your comments about the need for interdisciplinarity goes in the same direction, that there's really a lot of work to be done, and bringing people on board and working on our methods of collaboration and getting ourselves out of our silos and traditional ways of doing things. So that's what we're all about at the in the Energy Evaluation Network, as well as obviously like-minded people that we've managed to get here today. So thank you all for coming. Thank you to the speakers in particular, but very much to the panelists who've shared their views, and to all of you who came to listen and contribute questions. I think he warned us that this would be recorded, so we will circulate this again if anyone would like to relook at it. And we'll talk to Philippe and Joeri about the potential to share some of the material, and certainly the published report. And of course, do let us know if you'd like, if you're not already on our mailing list and you like the sound of the discussion so far, get in touch and we'll join you up, because there is more webinars to come this year. So with that, we're 4 minutes over, but thanks everyone for hanging in there for a really interesting discussion, and enjoy the rest of your day or night, depending on where you are.
Thank you for having us.
Thank you so much, Nina.
Thank you so much, Nina. Thank you.
Great, thanks a lot.